Okay, so hello. This is the last topic for midterms for Clinical Chemistry 1 lecture. So in the previous topic, you have learned about various concepts regarding quality assurance and quality control. So now we're going to focus more on the solving part of quality control as well as, of course, um, I know you're very familiar with it already, but of course, we need to review it. No? Okay, importante ito masyado. So the objectives for this video lecture is to identify and solve the statistical tools that are relevant in making you're very familiar with this, the Levy-Jennings chart. No? A chart that we use to detect errors in a laboratory method. And of course, another objective of this video lecture is to be able to apply the Westgard multi-rule system in error detection in your through the use rather of your Levy-Jennings chart. Okay, so let's begin with the first, and that would be your mean. The mean, to solve for the mean is very simple, right? No? So the mean is described to be the best estimate of the analyte's true value for a specific level of control. So this is the formula for the mean. Okay, so how are you going to solve for the mean? Very simple. You're just going to add the data values and then you're going to divide it, the sum, you're going to divide it to the number of data values and you will now get the average or the mean. So just like in this example, if you have here 5 control data values, so you're just going to add these 5 numbers and then you're going to divide it to the number of values and you will now get the average. So that's for the mean. Then another statistical concept that we also need to remember when we talk about Levy-Jennings chart or when we talk about making Levy-Jennings chart is your standard deviation. So in standard deviation, we look here as to how close the numerical values are, the control values are in relation to each other. So if you have, for example, you have solved and then you have acquired a low standard deviation, then that implies that the data points are very close to the what? To the mean. Okay? So to the mean. Kapag naman po mataas yung standard deviation, then it implies that the data values or the data points are spread out over a large range of values. Okay? So this is now the formula for standard deviation. By the way, in your scientific calculators, there's actually a shortcut for you to solve for the mean and standard deviation. So I'm going to teach you that one in the synchronous session na lang, okay? So ang alam ko lang na shortcut is through the use, or rather with the use of yung Casio na calculator. So dun sa mga ibang scientific calculators na hindi the same sa akin, so sad to say hindi ko alam on how to do it, Pero with my calculator na Casio na scientific calculator, I can teach you how to do the shortcut, to solve for the mean and standard deviation, especially itong CSD kasi 'di ba, yung manual na pag-solve ng SD is very tedious and very long. So I'm going to teach you the shortcut for that one. Now, talking about standard deviation as well, it is also used to set up the limits. Okay, this is what we call limits. So how do we solve for the limits? So this is the formula. Okay, by the way, you need to remember how to solve for the limits since those are also part in making your Levy-Jennings chart later on. So the formula for the limits, we have here mean plus minus standard deviation multiplied to 1 for 1 SD na part ng ating Levy-Jennings chart. Like for example, if you have a lower, if you want to solve for a lower limit, so mean, for example, kung i-base natin dito na example, ang mean niya is 4.56. So 4.56 ang isa-substitute mo sa formula minus, lower limit man ang gina-solve. So minus yan siya ang gagamitin, Minus 0.1 times 1. So the answer would be 4.56 4.46. So that will be now the lower limit for 1 SD. For higher limit naman po, papalitan mo yung minus ng plus and then you'll get 4.66. No? So the lower limit for 1 SD is 4.46. The higher limit is 4.66. That's for 1 SD. How about for 2 and 3? No? Actually, the formula for calculating limits for 2 SD and 3 SD and even 1 SD, they are almost the same. Ano lang po yung mag-change? Yung number na minumultiply mo sa standard deviation. So in this case, kapag ang hinahanap mo na limits ay for 2 SD, so ang imumultiply mo sa standard deviation in this formula is 2. And then for 3 SD, ang imumultiply mo ay 3. Okay? Now, in the normal distribution of values, no? If you're going to go back to your statistics, diba? In the normal distribution of values, you need to remember that when we consider only the 1 SD, no, it's expected that 68.3% of the values will fall in this or within 1 SD. Okay? For 2 SD, expect, no, normally in a normal distribution of values, expect po na within 2 SD makikita dyan 95.5%. And then para sa 3 SD naman po, you expect na makikita within 3 SD 99.7% of the values. Okay? So now, we have already reviewed how to how to solve for the mean and for the standard deviation. We have also reviewed already how to calculate the limits. So now it is already possible for us to create the Levy-Jennings chart. So hello. Okay? So nandito na naman siya. So as you can see here in the Levy-Jennings chart, no, you can define it or you can describe it actually as a graph of all the quality control results, no, in a month. So why ko sinabi in a month? Kasi po, in a clinical laboratory, dapat po sa isang month, makarun kayo ng a minimum of 20 controls. Yes, so 20 controls yan siya. A minimum sa isang month. So, when I say all QC, graph of all QC results, not all na, meaning no, hanggang sa nagsimula ang laboratory hanggang sa kung kano sa man siya mabankrupt, no? Yan hindi yan ibig sabihin ng all, no? Ang ibig sabihin po ng sinabi kong graph of all QC results, yung all doon pertains to the 20 controls that you are running per month. Okay? So, in your Levy-Jennings chart as well, you can also see, no, that in the y-axis, that's actually the concentrations, no? And then at the middle, that's the mean, no? And then going up, you have there the +1 SD, the +2 SD, and then the +3 SD. So dito na mapafall yung mga sinolve nyo na mga higher limits kanina for 1 SD, 2 SD, and 3 SD. And then sa baba po ng mean, ito yung mga lower limits. Ito yung sinasolve ninyo kanina rin, no? So this is -1 SD, -2 SD, and then -3 SD. So, ito sila, mga concentrations yan sila. No? You can describe them as concentrations pa rin. On the x-axis naman po, ano makikita dyan? On the x-axis, makikita nyo yung day, kung kailan siya gi-run. Okay, so for example, this one is day 1. Or others, hindi po day yung label nila dito sa x-axis. May iba po na they consider the x-axis as the number of run, no, na ginawa nila. Like for example, this one is the first run, no, of quality control, or rather the control material. And then this one is the second time na gi-run nila ang control material. And then this one is the third, the fourth, and the so on and so forth. Okay, so it's also important na you observe or you try to really look, no, into the Levy-Jennings chart presented. No? Kasi may iba, yung number of run no? Kung kailan siya ikailan siya na-run, no? Yun yung nilalagay nila dito sa x-axis. Meron naman din po iba yung day, no? Especially doon sa mga clinical laboratories na nagre-run ng controlled materials per day lang. Okay? Pero I also would like you to remember na theoretically or ideally, hindi yan siya dapat per day lang na gina-run ang control. Theoretically po, dapat at the beginning of each shift. So, di ba, sa laboratory, we have 3 shifts usually. Yung common na 3 shifts, you have 7 to 3, 3 to 11, and then 11 to 7. No? Yung night shift, 11 to 7. So, that means in one day, approximately, exactly 3 times ka mag-run ng control. No? But in the real settings of class, once lang. Okay? Unless na lang magka-problema, that's the time na more than once. Or di kaya, dun sa mga big hospitals like SPMC, no, na maraming tinetest na samples, dyan, more than once. Pero dun sa mga, mga maliliit lang na laboratories class, mga freestanding na laboratories na maliliit lang, ano lang yan sila, no? Once per day. Okay? So, kaya po, bantayan natin yung x-axis ng Levy-Jennings chart. Okay? Okay. So, aside from the mean, the standard deviation, no? The solving of the limits, you also need, when talking about quality control, you also need to remember the concept of coefficient of variation, because this one is also very important. Okay, in evaluating the methods that you do inside the laboratory. So your COVAR, or your coefficient of variation, is a measure of variability. So this is the formula for the coefficient of variation. So as you can see in this formula, it is expressed in %. Okay? So to calculate for the coefficient of variation, you still need the standard deviation, no? The mean, you also need that one, no? So that's for your COVAR. Now, what is the significance of calculating your coefficient of variation? So the significance actually is, of course, no, it is useful for comparison of precision between 2 methods or 2 instruments. So let me give you an example. For example, you are assigned in a hematology section, okay? And then, ikaw yung section head. And then, may may isa ka munang machine. No? For example, may isa kang machine for CBC. No? Isa lang yung machine yung for CBC. No? Ngayon, may isang medrep, no? Lalapit siya sa iyo na, ay ma'am, good morning. Ako po yung medrep na may appointment sa inyo. Okay? So, ito po yung machine ko. So, the question now there would be, gaano ba kaganda yung machine ng medrep na yon? Okay? So, one way on how to evaluate the machine of that medrep is through coefficient of variation. So, titingnan mo ngayon, no, if yung results ba ng machine, no, close doon sa results ng machine na nasa lab nyo na. Again, ang ginagawa natin dito, no, utilizing coefficient of variation, kung merong bago na machine, no, para malaman natin if maganda ba yung ino-offer ng medrep na bago na machine, no, you can calculate coefficient of variation para ma-compare mo yung precision ng dalawang instruments, yung bago at saka yung nasa laboratory mo na talaga. Okay? So that's the importance of CV. Okay? You can also actually use CV, no, aside from that scenario, you can also actually use CV, no, when you want to perform patient's precision testing. And remember, the lower the coefficient of variation, the better. Okay? Now, we have also this what we call standard deviation index. So what is this one? This is a statistic that measures your lab's bias relative to your consensus group. Usually, the consensus group referred to here is the reference method. No? Makikita nyo actually sa Bishop. Sa Bishop, chapter 3, I forgot the page, no? Basta nasa chapter 3 method evaluation. Sa definition of terms niya, so naka-box yun siya. And then nasa bottom part, nakasulat po doon, no? Instead of consensus group, reference method yung kanyang sinulat dito. Okay? So usually po kasi, when calculating SDI, no, reference method yung tinitingnan. Okay? So, pero meron ding other references na nagsasabi na aside from the reference method, pwede mo rin ilagay dito yung tinatawag nating interlaboratory group. Okay? So when we say interlaboratory group, so kukunin mo yung results ng iba't ibang laboratory and then you calculate for their mean and standard deviation. Okay, but again, for SDI, ang mas common po is yung reference method. Kasi yung reference method standardized na po kasi yun siya. No? Okay? So, doon talaga tayo sa standardized kasi yun yung mas better. Okay? So, this is the formula for calculating the SDI. So, your SDI class now is very useful if you want to test an accuracy of a method. Kasi baka your laboratory kasi baka merong modifications in the protocols or the SOPs of a laboratory test, or perhaps you have your own unique method of performing a lab test, no? So para ma-assure yung accuracy ng method na ginagawa ng laboratory, so you can do your SDI. Okay? So how do we interpret the values or the results after calculating the SDI? So after calculating SDI, if the result or the computation results to 0, that is the ideal score. In other words, this means that the data values of the laboratory are in 100% agreement with the consensus group or the reference method. So you can definitely say that the lab method that you are doing or employing in the laboratory is accurate. Okay? Pag naman po, positive, negative 1 to 1.5 ang nakuha mo na value after calculating SDI, that is still acceptable. But mas better po if you will start now investigating for test system bias. Okay? And then, kapag umabot na siya ng plus minus 1.5 to 2, so this now needs corrective action. So what does it imply? It implies that the method is already giving inaccurate results. No? Actually, ito very strict nga siya kay 1.5 to 2. Sa libro ni Bishop, it's 3. So sir, 3 mo pala sa libro ni Bishop. Saan mo nakuha itong 1.5 to 2? Kung isi-search sa internet, merong isang company, if I remember it correctly, Abbott man siguro to. Later, baka ma-remember ko, na mas strict ang kanila, 1.5 to 2. Okay? So, yun siya. Now, let's proceed to your CVR or coefficient of variation ratio. So this one naman po is a statistic that compares your lab's precision to that of other labs in a consensus group. So nandito pa rin po yung consensus group. But in this case, for your CVR, ang mas common po dito, or hindi siya common, only, ang only ginagamit dito is yung interlaboratory group na CV. Okay? Hindi po reference method. Bakit po? Kasi ang tinitingnan kasi natin sa CVR is already precision. Kanina sa SDI, accuracy ng laboratory method mo ang tinitingnan natin. Okay? Kaya better talaga and mas preferred na sa consensus group ang gagamitin ay yung reference method na mean and standard deviation. For CVR, since this is only precision, the closeness of the values, so we're just going to get the interlaboratory group CV. Okay? So this is the formula now for your CVR. And then to interpret the result, if after solving you get less than 1, then that means that the method has an acceptable performance and your precision is good. Okay? Pag 1 to 1.5, kailangan na natin magsimula ata mag-investigate ng test system imprecision. And then, no, ito na naman, mas strict po. 1.5 to 2. So, pag 1.5 to 2 raw po, no, definitely imprecise na po yung laboratory method mo. Okay, so, kailangan may adjustments kang gagawin, corrective actions na gagawin, no? So, by the way, na-remember ko na po, itong mga interpretations natin for the values of SDI and CVR, no, ang company pala is the Biorad. Okay, Biorad. Okay, so that's for your CVR. Now, let us proceed with another concept that is very important when talking about quality control. The quantitative aspect of quality control, we have the shift. Okay, so shift is defined as an abrupt change in the control values. By the way, let me ask you, what is the criteria for you to say na, uy, meron ng shift? Sa tingin nyo? Okay, so yung criteria natin dito, kapag 6 or more consecutive QC results fall already on one side of the mean, you can already say na may shift na. Okay? So, malay mo yung 6 consecutive values na yon nasa taas lahat, o di kaya nasa baba lahat. Okay? So, you can now definitely see that there is a shift. Okay? If that will happen, no, the recommendation of the World Health Organization is you reject the results. Okay? So, no, masakit man ang rejection, but you need to reject the results if that will happen. No? Yung shift. So, this is an example. Actually, kulang pa nga ito. No? Ito, malapit mo na itong masabi na shift siya kasi itong 5 data values natin, they are on the same side of the mean, no, nasa taas. The moment po na dito sa, anong day na ba ito? 14. So pagdating natin sa day 15, pag nandito pa rin yung, nandito, basta nandito pa rin sa taas yung control result natin sa day 15, you can definitely say that there is already a shift. Okay? Pero kung dito siya sa baba, oy, at least, okay? So, hindi, yung 6, supposedly 6 na consecutive data value, hindi na niya tinuloy dun sa taas, dito na siya sa baba. So, hindi mo na i-reject yung results. Okay? So, what could be the possible causes of shift? So, these are the possible causes of shift, class. You can actually read them on your own na lang. No? What I would just like to tell you is that what is common among the causes is that they all affect the reading of results in some way. No? Like for example, sudden failure in the light source. So paano makaka-read ng result ang machine ngayon kung wala siyang light? Right? So ganun, no? Now, we also have this what we call trend. Okay, so kung si shift po, there is an abrupt change. In trend po, there is only a gradual loss of reliability. So when we say gradual, no, slowly. But even though it's slowly, it is still continuously happening. Okay, so the trends, no, occur when values gradually but continually they move in one direction. And same, no, when can you say that there is already a trend? No? When they are moving in one direction, for example, paakyat ba ng mean or pababa ba? No? They are moving in one direction and then you're again considering over 6 or more control runs. Okay? Pag 4 pa lang yan, hindi mo pa pwedeng sabihin na, uy, may trend na. Okay? So same sa shift kanina. Kailangan makabilang ka muna ng 6 na data values. Pagdating sa ika-6, no, that's the time that you can say na, uy, there is already a trend. No? And of course, same with your shift kanina, dapat po yung data values sa trend, no, they are seen on one side of the mean only. Okay? Hindi mo pwedeng sabihin trend kung ang first 3 values na tinitingnan mo is nasa baba, tapos yung next 3 nasa taas. Okay? Dapat pa rin po, no, on one side of the mean. Okay? Same sa shift, one side of the mean sila dapat. No, yung minimum na 6 na titingnan natin. No, na nagfo-fall on one side of the mean. And same with your shift as well. If there is trend, no, the results will be rejected. Okay? So we have here an example of a trend. So this one is 1, 2, 3, 4. So kung wala pa itong tatlo na ito, itong 4 lang ang meron, it's not safe pa to say that there is a trend. But kapag ganito na po, pareha sa ating example, 1, 2, 3, 4, 5, 6, o 7 na nga ito siya. So you can really say, no, it is already safe to say that there is a trend that is happening. And as you can see here, no, gradual, no, from this data point, nung nagsimula ang trend, no, gradual ang pag-increase. Okay? Compared kanina sa shift, no, na from this point, bigla lang nag-change. Okay? So what are the possible causes kung bakit may trend? So these are the possible causes. Okay? So what is common among them? Of course, I think you will observe this one. We have the keyword gradual. Therefore, the effect of these will affect the result bit by bit lang. No, hindi drastic. Okay? So it's also very important to remember, no, that trends or shifts are, again, indicative of a problem. So you need to investigate and definitely correct them. Okay? Now, let us proceed into this what we call systematic and random error. So what's the difference between the two? Systematic error class is not acceptable because this one indicates that there is some failure in the system, no? And of course, that should be corrected. So good examples of systematic error would be your trend and your shifts. Okay? So kung may makikita ka mga trends and shifts sa Levy-Jennings chart mo, so you're already observing a systematic error. Now, with random error naman po, there will be a variation in quality control results that shows no pattern. Okay? So this type of error generally does not reflect a failure in some part of the testing system. And of course, therefore, it's not likely to reoccur. Okay? Not likely, but there is still a chance, no, na mag-reoccur ang random error. Okay? Pero that's very rare lang. Okay? So random error is only a cause for rejection if the data value na nag-cause ng or nagre-reflect ng random error, no? Again, random error is only a cause for rejection if yung data value na nag-show ng random error exceeds plus minus 2 SD. Okay? Okay. Now, the next thing that I would like to let you remember, no, na sa isang laboratory po, for example, ikaw yung naka-assign sa clinical chemistry. Kapag po yung laboratory nyo or yung machine na ginagamit nyo sa clinical chemistry, isa lang po yung control na ginaran, no? So, ang gagawin mo lang po, isang rule lang po yung kailangan mong tandaan. Anong ruling yon? If one control lang po yung ginagamit ng machine, for example, or ng laboratory method, for example, no? Ang kailangan nyo lang pong tandaan, the values in the, or rather the values of the control results are said to be, quote-unquote, in control. No? So the values are said to be in control if they fall within the plus minus 2 SD. Tapos, kapag kahit isang value lang, no, na lumampas ng plus minus 2 SD, considered na yun siya agad na out of control. Then we reject the run and do corrective action. Okay? So yun lang po yung kailangan tandaan. Kapag, again, yung isang laboratory, meron siyang machine and that machine nag-utilize lang ng isang control. So you're only running one control. So you just remember, no, that the values will be said or will be described as in control if it is within 2 SD. And then if there is just one value that will go outside the plus minus 2SD, then that value will be considered automatically as out of control. Then we will reject the run and we will do corrective action. Okay? Now, most or what is more common, no, is laboratories use machines or lab methods that utilizes two controls. The moment that you use two controls or more than two controls, then that is the time that you need to apply this what we call Westgard multi-rule system. Okay? So kung isa lang yung control, hindi pwede na na gamitin mo yung rules ng Westgard. Okay? Minimum of 2 or more. No? So, two controls. Okay? Usually, ang controls niyan, isa normal and then yung isa abnormal. Meron naman din pong iba, tatlo yung controls nila. Yung isa normal, yung isa abnormally low, and then yung isa abnormally high. Okay? Pero for this video lecture, we will not deal with three controls. No? Kasi may set of rules din tayo, another set of rules din tayo para dyan. Kapag three controls na yung ating kino-consider sa Westgard. Okay? Importante lang ngayon, sa inyong level din, is alam nyo po paano i-apply ang Westgard sa two levels. No? Kapag ang laboratory may two levels of control sa isang machine. Okay? So normal, abnormal lang muna. Huwag muna tayo dun sa normal, abnormally low, and abnormally high. Okay? And as far as I can remember, when I was working in, what do you call this? When I was working in a laboratory, sa chemistry nga, no? Nung naka-assign ako sa chemistry, isang control nga yon. So, hindi mo pwede gamitin ang Westgard. No? Ang gagamitin mo lang is yung rule na sinabi ko kanina for one control. Pero may iba, no? Two controls ang kanila, no? Normal, abnormal, and then may iba din, normal, abnormally low, and then abnormally high. Okay? So, since I have mentioned now the Westgard multi-rule system, so let us now discuss that one. Okay? So, this one is a multi-rule system. When we say multi-rule, it's not only one rule, it's a set of rules. Okay, so it's a multi-rule system developed by Dr. James O. Westgard based on statistical concepts. So it is a combination of decision criteria or rules to assess if a system is still in control or already out of control. Okay, so hindi siya parehas dun sa one control kanina na agad-agad mo masasabi na, uy, out of control. Uy, in control pa rin siya. Okay, dito, meron tayong mga i-consider na ng mga criteria. Okay, before mo masabi agad na out of control or in control pa rin. Okay, and again, as I have emphasized in the previous slide, this is only applicable if the machine or the laboratory is utilizing more than one. So that means two or more controls. Okay, so let's begin with those rules. Or mamaya na lang. Sige. Let's begin with this rule muna. This rule is the first one that I would like to present to you because this is only a warning rule. No? Yung ating 1 to 2S. So, warning rule siya kasi po kapag mag-o-occur itong 1 to 2S, magwa-warn, it's already a warning to us na there could be a possible random or systematic error that's occurring. Okay, so how will we know that there is already or this is already happening, no? Na meron ng value sa ating chart, no, na maa-apply ang 1 to 2S rule. So, when we say 1 to 2S rule, there is already a one value, no? There is already a value that is outside the plus minus 2SD. The limit. Okay, that's 1 to 2S. But again, that is only a warning. It's not a course, it's not a cause, rather, it's not a cause for, or it's not a reason for rejection pa. Okay, so warning lang yan siya. Now, let's proceed with the other rules. So the next succeeding rules that I'm going to discuss are those rules to detect systematic error. So the first one would be your 2 to S rule. So in your 2 to S rule, there are 2 data values that occurs outside the plus minus 2SD. Okay? By the way, baka kasi ma-confuse kayo, there are those laboratories na isa lang yung Levy-Jennings chart na ginagamit nila, and then nandoon na makikita yung results ng dalawang levels of control, no? Yung normal at saka yung abnormal. Meron naman din po ibang laboratories na they separate the chart, no? May isa, for example, yung first Levy-Jennings chart nila, para sa normal, and then yung next is for the abnormal. Okay? Well, kung saan naman ang susundin, depende po sa policy or protocol ng laboratory na pinagtatrabuhuan nyo. Okay? So this one, no, makikita nyo, dalawang data values occurring outside the 2ST. So that's 2 to S, and that already indicates a systematic error. Another one, 4-1S rule. So 4-1S meaning there are 4 consecutive, take note, consecutive dapat ha, 4 consecutive controls on one side of the mean that exceeds your plus minus 1 SD. Like in this case, ito. So, 4, no, occurring outside the plus minus, in this case, the minus. Okay, nasa baba man ang mean, the minus 1 SD. Okay? So, that indicates systematic error. Then we also have your 10x. So, this one systematic din ito siya. So, this indicates systematic error. And then, 10x means that there are 10 consecutive controls on one side of the mean. Parehas po nito. 10. Okay? So, ganun po. Okay? Okay. So, what are the possible causes of systematic errors? Ano ba yung mga nagko-cause, no? Kung bakit sa ating Levy-Jennings chart, makakakita tayo ng 2 to S, 4-1S, 10X, no? So, these are the possible causes. First, improper alignment of sample of reagent pipettes resulting to change in reagent and calibrator volume. Like for example, ang kailangan na volume of reagent is 500 microliters. Tapos, due to misalignment, no, of the pipette and the container for the reagent, no, 250 microliters lang ang nakuha ng machine. So, yan, magkakause yan ng systematic error. No? Source yan siya, systematic error. Another one, no? Like for example, yung calibrator, no? Na mali sa machine pag-read kasi nakulangan yung volume ng calibrator na pinasip mo sa machine. Okay? So, that could also cause a problem. No? That would also be a source of systematic error. What else? No? Drift or shift in incubation temperature. Kasi di ba, remember, going back to your biochemistry, temperature can affect the rate of chemical reactions. Right? Okay? And then, ito, deterioration of photometric light source. Why? Because remember, di ba, light has a very important role, especially if the machine is utilizing spectrophotometry. Okay? So, paano ngayon magbabasa ang machine? Paano ngayon magbibigay ng result ang machine kung wala siyang light source? Okay? So, yun siya. No? Then, change of calibration or reagent lot. Okay? Magiging source of systematic error yan. Especially kapag nag-change ka ng lot, tapos wala ka nag-perform ng calibration of machine again. No? Makaka-observe ka ng systematic error niyan. What else? Deterioration of reagent. Okay? So what else? Incorrect handling of control product. Like for example, wala mo gi-protect from light ang control material. Tapos, pag may-measure ka pala ng bilirubin sa control material mo. Okay? So, source of systematic error again. What else? Inadequate storage of reagent or calibrators. Like for example, dapat naka-ref siya or naka-freeze siya. Pero, wala mo inayos ang pag-ref no? Or di kaya, supposedly naka-freeze siya pero gi-ref mo. O di kaya, nakalimutan mo na i-ref or i-freeze balik kasi nga, busy ka masyado. No? So, yan. Magiging source of systematic error yan. And then lastly, of course, change in test operator. No? Especially if ang pulihan na mag-operate sa machine is hindi masyado ganun kagaling or hindi masyado knowledgeable on how to do properly quality control. Okay, so ganun po. Sources of systematic error yan sila. Now, let us proceed to the rules that will allow us to detect random error. And the first one is your 13S. So when we say 13S, there is only one data value that occurs outside the plus minus 3 SD. Okay? Parehas ito. So, pag may ganito, 13S na yan siya. It already violates the 13S. Then we also have the R4S. So, itong R4S, dapat talaga titingnan mo sa R4S is may dalawang data values na ang difference po nila ay ano? Dalawang data values na ang difference po nila ay 4 SD. Okay? So that's R4S. And again, that is a random error. Okay? So what are the possible sources of random error? Power supply. Okay? Double pipetting. Usually this occurs kapag may glitch or may lag sa machine. And then, misplacement of control sample within the run. So, namali si Medtech, no? Kung asa dapat ibutang ang control material pag nire-run sa machine. And then, random air bubbles. Because, air bubbles can affect the volume, no? That will be sipped by the machine. Okay? So, sources of random error yan. What else? Incorrect reconstitution. Okay, like for example, instead na NSS, for example, ang ilalagay to reconstitute the control product, ang nilagay ng Medtech water. So, dapat basahin talaga ang instructions for reconstitution. What else? Inappropriate storage of control. Like for example, sabi ko kanina, nakalimot si Medtech mag-freeze. Dapat pala i-freeze siya. Inadequately mixed reagents. No? Like for example, di ba, ang quality control, ginagawa siya at the beginning of each shift. Tapos si Medtech, busy sa cellphone. Okay, no? Social media is live before work. So karon nakalimot si Medtech to mix the reagent. No? So that will be a source of random error. And then the fourth one, this one is already dependent on the operator o sa skills ng operator. Okay, so pwede rin yun maging source of random error. Okay? So let's proceed to the next slide. So what does this tell us? No? This slide tells us that if there would be a bias in the laboratory method, okay, this is what you will observe in the Levy-Jennings chart. So ano ang nakikita nyo? Nakikita nyo, they fall only on one side of the mean. No? And this is already a 1, 2, 3, 4, 5, 6, 7, 8, 9. This is actually violating already the what Westgard rule? The 10x, right? Okay? So, no, ito yung possibly makikita nyo kapag may bias or pangit yung SDI result. Okay? Kapag naman po, ang problema mo is in terms of precision, no? Yung CVR or CV, R to siya dapat. Yung CVR or CV ang may problema or yung repeatability ang may problema. So ito po yung possibly ma-observe nyo sa Levy-Jennings chart. No? So makikita nyo talaga na the data values are very far from each other. And patuloy silang lumalayo. Okay? So, ano pala talaga yung ideal na itsura ng isang Levy-Jennings chart na in control, no? Kasi ito siya out of control na ito siya, no? You can already consider it, especially ito, this is already out of control because this is already violating a Westguard multi-rule. This one is also out of control na. Okay, kasi may violate na rin ito na Westguard multi-rule. So, ang ideal po talaga, no, is ganito lang yung magiging itsura niya, di ba? The values are very close to the mean, so that means the values are accurate. Huh? And then they are still close to each other, so that means they are also precise. No? Yan naman yung pinaka-importante, di ba? Accuracy and precision. Okay? So, the next question now would be, given the Westguard multi-rules, no, how do we know, or what will be our guide to determine if we are going to consider the control values as still in control or out of control? Okay, so I actually saw a diagram, no, which can be your guide to determine if you can safely say that it is in control or out of control, no, yung mga data values natin sa QC. So ito siya. So you have here the control data. So kapag po warning rule lang, no? And then pagdating sa warning rule, ito lang yung kanyang na-satisfy or na-violate, no? Wala na siya naka-violate ng other rules, you can still consider the QC results as in control. So you're going to accept the running or the results. Okay? Pero if nag-violate siya sa 1.2s, nag-violate din siya sa 1.3s, then you can safely say that there is already an out of control, no? And you will reject the running. Or rather, you will reject the results of the control. Okay? So, tingnan niyo lang po ito siya na algorithm. Okay? So, the last question now would be, sige sir, if in control siya, so wala tayong problema. Pag in control, ang gagawin natin, no, magra-run na tayo next ng mga patient samples. But if from the Levy-Jennings chart, you will see that there's already an out of control, or this is what you're going to do. First, of course, you need to stop testing. Okay? Now, after stopping the testing, hindi dapat kukuha ng bagong control tapos ira-run ulit. O di kaya, i-repeat lang natin yung control kasi sayang mahal kasi ang control. Hindi po. Okay? So, anong gagawin kapag out of control yung quality control mo? Stop testing and then you first identify, no, bakit may out of control? So when you identify, what are you going to do? You need to inspect the control chart, no? Look if there are, or what are the Westguard rules na na-violate so that you can determine later on the type of error. No, kung random or systematic ang nangyayari na error. And then once na-detect mo na yung error, kung random or systematic, that's the time na pwede mo naman narrow down ano ba yung mga possible sources of or causes of random or systematic error. And then from those sources or causes, which of those yung most likely na nag-o-occur ngayon. Okay? And then pag na-pinpoint mo na yon, of course, you can now do corrective action or remedial action. But you need to take note, you need to take note that when you perform remedial or corrective action, you need to refer to established policies or procedures. Sir, saan yung makita yung established policies or procedures? Makikita mo yan either sa laboratory manual. Hindi yung laboratory manual na ginagamit nyo sa school, yung laboratory manual lang pinagtatrabahuan nyo. O di kaya yung manual ng machine ninyo. Okay, doon kayo titingin. Okay? And once you perform the corrective action, or once, for example, hindi nyo kaya, nagpatawag kayo ng engineer, once the engineer has done or had done the corrective action, of course, don't forget to document that one. Kasi malay mo, mangyayari yan ulit next time. Okay, so at least, alam mo na anong gagawin agad. No, hindi ka na maghahanap sa manual kasi ang manual kasi medyo makapal. Okay? So, yun lang po yung mga concepts na gusto kong i-discuss muna for this video lecture. In the synchronous session, what we are going to do in the synchronous session is first, we will make a Levy-Jennings chart. Okay? And of course, second, for you to know or to be able to identify, no, the possible violations of the Westgard multi-rule, no, Westgard multi-rules, given na may ibibigay sa inyo na dalawang Levy-Jennings chart. Okay? Or kahit isa lang, no? Kasi importante kasi dito, alam nyo paano mag-detect ng violation sa Westgard multi-rule and alam nyo paano tingin, no, if the control values are still present, if the control values are still in control or out of control. Okay? Also, before I end this one, it's also very important for you pala, no, to remember na the moment that you have perform the corrective action, tapos pag-run nyo ulit ng control, no, in control na siya, no, after doing corrective action, nag-in control na yung control material. So you're going to repeat again the testing on patient samples. Okay? And remember po, do not report patient results until na-resolve yung control problem mo. Okay? Okay, so see you in the synchronous session. We're going to make the Levy-Jennings chart at that time, as well as trying to identify violations in the Westgard multi-rule system. Okay, so thank you for listening.